Question 1. Using a calculator or otherwise, calculate the exact value of the following. So we have 4 1/5 multiplied by 1/3, subtract 1 1/4. So to find the exact value of this, since we are able to use a calculator, we can input our values. So it says 4, so you're going to click Shift and our fraction button, which gives us a mixed fraction sign. And then we're going to write 4 1 5 multiplied by 1/3. And let's write our answer for that. So we're going to have 2/5 subtract 1/4. And then we can continue on subtracting again. So our answer, subtract our mixed fraction symbol, 1 1/4. And that gives us our answer as 3/20. They're asking us for exact value, so we can keep our answer as a fraction, which is 3/20. And if we wanted to convert this to a decimal place, we can click this symbol right here, which would give us 0.15. Since it says exact value, we need to give it to the exact decimal place or fraction that they've given us. Next question, it says 4.1 minus 1.25 squared divided by 0.005. Once again, we can expand our squared number before we divide. So we're going to have 4.1 minus, and let's expand our 1.25 squared. 1.25 squared is going to give us a value of 1.5625. And then divided by 0.005. Now substituting our values, our fraction symbol again. Then we're going to have 4.1 subtract 1.5625 divided by 0.005. And that gives us our answer as 507.5. Or convert to decimal place, we're going to have 507.5. Part B, it says a stadium currently has a seating capacity of 15,400 seats. Calculate the number of people in the stadium when 75% of the seats are occupied. So we need to find 75% of our total amounts of seats, and we're going to know how many people are currently occupying the stadium. So as we know, percentage is always written over 100. So that's 75 over 100 multiplied by the seating capacity, which is 15,400. And to simplify our equation, we're just going to write this as a fraction as well. So we're going to put this over 1. And we can simplify by taking off our zeros. So now we have 75 multiplied by 154 over 1. So multiplying that, we will have 75 multiplied by 154 gives us 11,550. 550. So that's the amount of people that are currently occupying the stadium. Part 2 says the stadium is to be renovated with a new seating capacity of 20,790 seats. After the renovation, what will be the percentage increase in the number of seats? So to find this value, we need to find the increase. So the formula to find the increase would be our now seating capacity minus our original seating capacity, which was 15,400. So subtracting those two values, 20,790 subtracting 15,400, we will now have a value of 5,390. So let's check our value. 20,790 minus 15,400 gives us a value of 5,390. Now that we have our increase, to find what will be the percentage increase of the number of seats, it's our increase, which is 5,390 divided by our now seating capacity, which is 20,000. Sorry, by our original seating capacity, which was 15,000, 15,400. And then that's multiplied by 100 since we need to find a percentage increase. And once again, we can simplify. So now we have 5,390 divided by 154. And simplifying this, 5,390 divided by 154 would give us an answer of 35. What will be the percentage increase? So 35% increase in the number of seats. Question C. A neon light flashes 5 times every 10 seconds. Show that the light flashes 43,200 times in one day. So we know it flashes 5 times every 10 seconds. And show that the light flashes 43,200 times. So we know from 5 times to 43,200 times, I need to know how much we need to multiply by to get that value. And then we need to multiply that same number to get this value. So I'm going to divide 43,200 by 5 to find that value that we multiplied by. So that's 43,200 divided by 5, which gives us 8,640. 8,640. So that's what we multiplied by. So therefore we need to multiply here as well by 8,640. And that's going to give us a value of 86,400. So just adding another zero behind. Good. So now to prove our answer, we know that 60 seconds is equal to 1 minute. And we know 60 minutes is equal to 1 hour. And we know we have 24 hours in a day. So now if we're to multiply our seconds to minutes to hours, if we're to multiply that value, it would give us how many seconds are in a day. So multiplying 60 by 60 by 24 would give us 60 times 60 times 24 is equal to 86,400, which is the same exact value as what we got here. So that's how we prove that the light flashes 43,200 times in one day. Question 2. Factorize the following expressions completely. We have 5h squared minus 12hg. Now we need to search for the common number or letter in this expression, and from looking at this, h is the only common letter in our expression, so h is going to come outside of our brackets. And now we have h being 5h squared divided by h, which would leave us with 5h. So if we were to multiply back this, we're going to have 5h squared, which is what we're looking for. And then minus, so h into 12hg would give us 12g. So that is how we factorize that expression. Moving on to part 2, we have 2x squared minus x minus 6. We can use the AC method here. So that means our a, let us write our values for a. So we have a is equal to 2, b is equal to negative 1, which is this value here, 2 is our value here, and then we have c is equal to negative 6. So for our AC method, we have to multiply the value of a and c, which is 2 times negative 6, and that would give us a negative 12. 6 times 2 is 12, and the negative multiplied by a positive gives us a negative value. And after we find the AC, which is negative 12, we need to find two numbers. When multiplied gives us AC, and when added or subtracted gives us our B value, which is negative 1. So first things first, we need to write the factors of 12. So we're going to have 1 times 12, 2 times 6, and 3 times 4. And these are our factors of 12. Remember, we need to find a number when added or subtracted would give us our B value. So looking at these, this would not give me a minus 1 value. This would not give me a minus 1 value, but these two numbers can give me a minus 1 value. Now we need to look at our signs now. So remember, it has to multiply to give us a negative 12. And when added or subtracted, it has to give us a value of negative 1. So if we have a positive 4 and a negative 3, that would give us a value of a positive 1, which is not what we're looking for. But if we have a value of negative 4 plus 3, that would give us a value of negative 1. So our larger number has to be negative for us to have a negative 1 value. And then when we multiply 4 times 3 gives us 12. Multiplying a negative by a positive gives us a value of negative. So that's how we have our two factors. So with that in mind now, we're going to substitute our two factors for our B value. So rewriting, we're going to have 2x squared minus 4x plus 3x. So these are our two B values, minus 6. Now we're going to factorize. Similarly to what we did above, we're going to factorize. So I'm going to take these two numbers and factorize them, and then I'm going to factorize these two expressions. So looking at our first bracket, we have 2x squared minus 4x. We can factorize, or we can find 2 and x, which are common in both of these expressions. So we're going to have 2x outside of our equation. So 2x into 2x squared is going to leave us with x. And if we to multiply that, we're going to have 2x multiplied by x, which would give us 2x squared, which is what we're looking for. And then 2x into 4x, which gives us a minus 2. And if we were to multiply this back, we're going to have 2x multiplied by negative 2, which would give us a negative 4x, which is what we're looking for. And then our next bracket, we have 3x minus 6. 3 is the only common number or common unit that we have in this expression. So we're going to put 3 outside of our brackets, and 3 into 3x would give us x remaining, and then 3 into negative 6 would give us a negative 2 value. Now our two brackets are the same, which shows that our answer is correct. That proves our answer is correct. So if we had a positive value here, that shows that something went wrong somewhere. So this is just another way that we can prove our answers. So rewriting this value and this value is going to create our second bracket. So we're going to have 2x plus 3, and then we're going to have x minus 2, which is our answer. X plus 3 and x minus 2. And if we were to multiply back these brackets, if we were to multiply out these brackets, we're going to end up back with our original expression. B. Solve the equation r plus 3 is equal to 3 brackets r minus 5. First things first, to solve this equation, we need to multiply out our brackets. So we're going to have r plus 3 is equal to, we're going to multiply our 3 and r, and we're going to multiply by our 3 and our negative 5. So we're going to have 3 times r is equal to 3r, and 3 times negative 5 would give us negative 50. Since we're trying to solve the equation, therefore that means we need to solve for r, because r is our unknown. We need to put all our r's on one side of the equation and all our numbers on one side of the equation in order to solve for r. So first things first, we have r, we have 1r here and we have 3r here. So we can subtract this r from both sides of our equation. So we're going to subtract r. That's the first thing we're going to do. So r plus 3 subtract r, we're going to just have 3 remaining, is equal to 3r minus r, which gives us 2r remaining minus 50. Now we need to get rid of our 15. So to cancel that, we're going to add 15. So we're going to have 3 plus 15. And then we're going to have 2r here. So if we were to add 3 plus 15, that would give us 18 is equal to 2r. Now we need to find for our r, so we're going to divide, because 2 is multiplying by r here. So we're going to divide. So we divide by our 2, so we're going to have 18 divided by 2, which gives us 9 is equal to r. So our answer is r is equal to 9. Next part of our question, it says make k the subject of the formula. Our equation is 2a is equal to pi k squared plus 3t. We're trying to make k the subject of the formula, so we need to move everything away from k to have k by itself to get our answer. So first things first, we're going to move our 3t. So in order to move our 3t, we need to cancel it. So therefore, it's adding in this side of our equation. So therefore, we need to subtract it. So we're going to have minus 3t. That gives us 2a minus 3t is equal to pi k squared. Next things first, we need to get rid of our pi. Remember, we're trying to find for k, so we're going to move everything else away from k. So our pi is multiplying our k, therefore we need to divide by pi. So we're going to have 2a minus 3t divided by pi is equal to k squared. And since we're finding for k, we need to now get rid of our square. So to get rid of our square, we need to square root both sides of our equations. So we're going to have square root 2a minus 3t divided by pi. Remember, everything is square rooted, okay? And that is going to equal to k because our square root will cancel our square. So our answer is k is equal to square root of 2a minus 3t over pi. And then our final question, it says a farmer plants 2 crops, potatoes, It says a farmer plants 2 crops, potatoes and corn, on a 10-hectare piece of land. The number of hectares of corn planted C must be at least twice the amount of hectares of potatoes P. Write 2 inequalities to represent the scenario above. So our first scenario, let's read. A farmer plants 2 crops, potatoes and corn, on a 10-hectare piece of land. So therefore, our potato plus our corn, it has to be less than or equal to the 10-hectare piece of land. So when the farmer plants the potatoes and the corn, it has to be within that 10-hectare piece of land. So therefore, it has to be less than the plot of land the farmer has. So that's the first piece of information that we get. And that's going to be our first piece of inequality. Second inequality, it says the number of hectares of corn planted C must be at least twice the number of hectares of potatoes. So the number of hectares of corn C, it has to be at least twice the amount, so it has to be greater than 2p, and 2 hectares of potato. Twice means times 2. That's twice. So 2p. And that is our 2 inequalities. Question 3. The diagram below shows a hexagonal prism. Complete the following statement. The prism has how many faces, edges, and vertices? So for the faces, we have 1, which is looking in this direction. 1, 2, the bottom 3, on top 4, this side 5, this side 6, and then here 7, and here 8. So we have 8 faces, and then edges, which is here. So counting our edges, we're going to have 1, 2, 3, 4, 5, 6. So if we have 6 edges here, then we're going to have 6 at the back here as well. So that's 12 edges, 13, 14, 15, 16, 17, 18 edges. And then vertices is where our edges meet. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 vertices. Yeah. So we have the faces, which are the flat surfaces here, here, here. Our edges are the lines here. And then our vertices are where our edges meet. So at each point is our vertices, or vertex. Moving on. B, a sports club owns a field PQRS in the shape of a quadrilateral. A scale diagram of this field is shown below. And it says 1 centimeter represents 10 meters. In the following part, show all your construction lines. The field is to be divided with a fence from P to the side RS, so from here to somewhere along here, RS, so that the different sports can be played at the same time. Okay. Each point in the fence is the same distance from PQ as from PS. So it has to be equal distance. So we need an equal line dividing these two lines. And then using a straight edge and compass only, construct the line representing the fence. Okay, so we need to construct the line representing the fence, which divides P from here to side RS. So let's get out our compasses. To bisect this point. So to bisect this point, go to our compass, reasonable amount, not too large, not too small, and keep it about this length. And we're going to describe an arc. So from our question, it says each point and fence is the same distance from PQ, which is here to here, as from PS. So therefore, we're going to put our compass on this point here, which is the PS line. And we're going to strike another arc. And then we're going to put our compass with the same length, the same measurements of one arc. We're going to strike another arc on our PQ line where our arc touches the line. So there we have our arcs. And where our arc cuts or meets, that is going to be the point that we're going to be in for P. So using our ruler, we're going to draw a line from P all the way through that point. So this is our fence. And remember, we need to keep our construction lines because we have a lot of marks for that, so do not erase your construction lines. Good, so we finished constructing our line representing the fence. So this is our fence. And it says write down the length of this fence in meters. So we need to measure a fence. Measuring our fence, I have roughly 7 meters more or less, because it says 1 centimeter represents 10 meters. So my ruler is telling me 7 centimeters. Therefore, our answer in meters will be 7. 1 centimeter represents 10 meters, so it's going to be 70 meters. So that's the length of my line. I'm guessing you'll have like a plus or subtract 2 meters is going to be acceptable. So I'm guessing anywhere between 68, 67 meters to 73 meters should be acceptable. Moving on. We have a quadrilateral PQRS and its image P dash Q dash R dash S dash are shown on the grid below. So this is our image, our quadrilateral and its image. Write down the mathematical name for the quadrilateral PQRS. So this is pretty straightforward. This type of quadrilateral is called a trapezium, so that's one mark. And also look out for your spelling, because we don't want any weird spelling, trapezoid, trapezoidal. We don't need any fancy words, so please be careful of your spellings. Part 2, PQRS is mapped onto P dash Q dash R dash S dash by an enlargement with scale factor K about center C. So we have an unknown center C. Using the diagram above, determine the values A, B, and K. So we need to find that scale factor where our center of origin really is. So to find that K, it's going to be our image length divided by our original length. And just using one side of our quadrilateral, if we use QP, then our original QP is 1, and then in our image, oops, I'm so sorry. Yeah, so our K is going to be our image length divided by our original length. And if we use our diagram here, our original length QP is 1, and our image length is going to be 1, 2, 3. So our K value is going to be 3 divided by 1, which gives us 3. However, to find our center of origin, or point or coordinates, we can connect each point, so our Q to Q dash, and extend the lines P to P dash, R to R dash, and this all will be extended from a point of origin. So if we connect those points together, we're going to find our point of origin. So connect our Q dash to Q, our R to R dash, and our S to S dash, which is going to be a straight line, S to S dash and P to P dash. And that gives us our coordinate as somewhere hereabouts, which is -3, -4, 5, 6. So this is going to be -4. And this value is going to be, since this is 3, this is going to be 2, 1. So that's going to be 1. So it's going to be 4 along our x, -4 along our x, and a +1 up. So remember our x and then our y coordinate. Yeah? So our A value, okay, so our A value is our x value, which is -4. Our B value, which is our y value, which is a +1. And then our K value is 3. Sorry, once again. Yeah, so our A value is -4, which is our first value, or x. Our B value is our y value, which is +1, and then our K value is 3, as we've calculated there. Moving on to question 4a. The function f is defined as f of x is equal to 2x plus 7 divided by 5. Find the value of f of 4 plus f -4. What we need to do here is substitute our value in this equation here for when x is 4 and when x is -4, and we add those two values together. So first things first, f4 plus, let's separate this a bit, plus, and f is -4. F of x is -4. So our equation 2x plus 7 divided by 5 plus 2x plus 7 divided by 5. Our x here is going to be 4, so we're going to substitute that value. So we're going to have 2 times 4 plus 7 divided by 5 plus 2 times -4 plus 7 divided by 5. 2 times 4 is 8, and then, so we're going to have 8 plus 7 divided by 5 plus 2 times -4 is going to give us a -8 plus 7 divided by 5. Simplifying this, 8 plus 7 is going to give us 15, because 8 plus 8 is 16, so 1 less than 7, that's going to be 15. 15 over 5 plus -8 plus 7 is going to be -1 over 5. Simplifying here, we can have 1 over 3, which is the same as, let's continue here. So we're going to have 3 plus -1 over 5, negative and a positive and a negative. When they're multiplying, therefore we're going to have a negative. So it's going to be 3 minus a fifth. And simplifying that, or putting that into our calculator, we're going to have 3 minus 1 over 5. 1 over 5 is going to give us 2 4/5, or 2.8 as decimal. Or we can convert this to a mixed fraction, which would give us 5 times 2 is 10 plus 4, which gives us 14 over 5. So any of these three values is going to be our answer here. We can keep it in mixed fraction or 2.8. Any of it will be fine. Yeah. So to find our values here, once again, we substitute our f of x value, which is 4, into our formula here, and then our -4 into our formula there. We work that out, and then we add our values together. Be careful of your signs here, okay? If you don't know how to navigate your signs or how to multiply or subtract or whatever your signs, just use your calculator. You have it. So you can input 3 plus -1 over 5, and you're going to have the same value as 2 4/5 or 2.8. Yeah. So make use of a calculator, but it's better if you do know that when a positive and a negative sign meet, it's going to be a negative. Positive and a positive, or two same symbols, gives you a positive. Positive and a positive when multiplied or divided gives you a positive. And positive and negative, negative and positive, either way, two different signs, gonna give you a negative. Yeah, so this is just something that you should remember and always take with you into the exam. Very useful for any mathematics equation. Moving on. Part 2. We have A, which is calculate the value of x for which f of x is equal to 9. Once again, we need to substitute in our formula when x is equal to 9. So going back to our previous question, our formula is f of x, let's write this on top. So our formula, f of x is equal to 2x plus 7 divided by 5. Good. So we need to find for when x is 9. So 2, 9 plus 7 divided by 5. That is equal, oops, sorry, I misread that. It says calculate the value of x for which f of x is equal to 9. So we have our f of x formula. F of x is equal to 2x plus 7 divided by 5. That is equal to 9. Guys, please don't be like me. Read your questions properly. So it says this formula here is equal to 9. So therefore we need to find the value of x. Okay? So we're going to have 2x plus 7. Since we're trying to find the value of x, we need to move our 5. So since it's dividing, we're going to be multiplying our 5. So that gives us 9 times 5, and that's going to be 45. Moving our 7, so since it's adding, we need to subtract it to cancel it. So we're going to have 2x is equal to 45 subtract 7, which would give us 38. And then since we're trying to find for x, we need to divide it by 2 because it's multiplying here. So dividing by 2, we're going to have x is equal to 38 divided by 2, which gives us 19. Yeah, remember you can use your calculators to find these values as well. So x is going to equal to 19. Now it says hence or otherwise determine the value of f inverse 9. So the inverse of f of x, so f inverse 9. First things first, we need to find the inverse of f of x. So since we have f of x is equal to 2x plus 7 over 5, to find the inverse of f of x, we're going to change our f of x into y is equal to 2x plus 7 over 5. So to find the inverse of this, first things first we're going to do is make x the subject of the formula here, which is what we did here. So we made x the subject of the formula. So doing that all over again, we're going to have y multiplied by 5. So that's 5y. Remember it's dividing, so we're going to multiply by 5 here is equal to 2x plus 7. And then we're going to subtract our 7. So we're going to have 5y minus 7 is equal to 2x. And then to find for x, we're going to divide by 2. So we're going to have 5y minus 7 divided by 2 is equal to x. To find the inverse of f of x, we're going to change our x to y and our y to x. So we're going to have 5x minus 7 over 2 is equal to y. And this is our f inverse formula. So now that we have that formula, f of x, f inverse x is equal to 5x minus 7 divided by 2. So that is our formula now. Now we need to just substitute our 9 value. That is going to be 5 times 9 minus 7 divided by 2. Simplifying this, we can multiply 5 times 9 using our calculators. You can multiply 5 by 9, which would give us 45, minus 7 divided by 2. So 45 minus 7, as we know, we're literally working this again. So 45 minus 7 gives us 38. And that's divided by 2. 38 divided by 2 gives us 19. So our f inverse of 9 gives us the same value, 19. This is a bit messy, but hope you understand the process. Yeah, our inverse, F inverse formula. And we substituted back our values, which gives us our answer as 19, which is the same as our f of x value. Moving on. Part B. The graph below shows two straight lines, L1 and L2. L1 intersects the x and y axis at 4, 0. So at the x-axis at 4, 0 and y-axis as 0, 2, respectively. And then L2 intersects the x and y-axis at 1.5, so x at 1.50 and y-axis at 0, -3, respectively. Determine the line equation of line L1. So to find the equation of line L1, we need to first find the gradient. So we need to write our equation L1 is equal, we need to write it in the format of y is equal to, not equal, y is equal to mx plus c. That is the expression or equation of a straight line formula, and that is how we need to write our line. We don't know our gradient, so we need to calculate the gradient of line L1. So to find the gradient of a line is equal to our y values. So that's our rise divided by our x values. So that's y2 minus y1 divided by x2 minus x1. So we can choose two points on our graphs and we subtract our x and y values for them. So I can choose these 2 points and we form our little triangle. Our coordinates for this point is 4, 0 and our coordinates for this point is 0, 2. Remember x and our y values. X then our y value. So I'm gonna label, I'm gonna label here x1, y1, x2, y2. Substituting our value, so y2 is 2 minus y1, which is 0, divided by x2, which is 0. Subtract our x1 value. Subtracting our x1 value, which is 4. Our m is equal to 2 minus 0 gives us 2, and then 0 minus 4 gives us -4. Simplifying that, we're going to have 2 into 2, 1, and then 2 into 4 gives us 2, which gives us our answer as -half. Rewriting our equation of the line, we're going to have y is equal to m, which is -half, and then x plus c. That is the equation of line L1, or we could even input the value of c for L1, which is 2. That's where it's the y-axis. Y is equal to -half x plus 2. Yeah. Moving on. Our next question asks, what is the gradient of line L2 given that L1 and L2 are perpendicular? So our line L1 and L2 are perpendicular. That's what the question says. And from what we know, the product of perpendicular lines are equal to -1. So if we're to multiply the gradient, the gradient of the perpendicular lines. So if we multiply M1, gradient of the L1 line, multiplied by the gradient of L2, it's going to equal to -1. Since we know the gradient of M1, which is -half, multiplied by M2, it's going to equal to -1. We can find our value for M2, which is going to be M2, since our -half is multiplying by M2, it's going to be -half. It's going to be -1 multiplied by our -half. And that's going to give us our M2 value of negative multiplied by negative is going to give us a positive. And since it's multiplying, it's going to be dividing, sorry. Silly mistakes. Yes, so it's multiplying here, therefore it's going to be dividing over here. And when we're dividing fractions, what we need to do is we're going to have a -half, and we can change our fractions to a multiplication, but that means we'll need to flip our fraction, which is going to give us 2/1. So multiplying that now, we're going to have M2 is equal to negative, and a negative gives us a positive, and 1 times 2 is going to give us 2/1, which is the same as M2 is equal to 2, which is the gradient of our L2 line. Question 5. A group of 100 students estimated the mass m grams of a seed. The cumulative frequency curve below shows the result. So we have our cumulative frequency curve. A, part 1, it says, using cumulative frequency curve, estimate the median. As you know, median is the middle value. Since we have 100 students, therefore the middle, let's have a ruler. So therefore our middle value would be 50 students, where 50 students, the number 50 students. So we need to draw a line from 50 touching our curve, and then from that line we're going to plot a line straight down to find the mass of seed. So doing that, we're going to plot our line across. Oops. And then we're going to draw a line down. So it touches here, so I'm going to plot a line straight onto the x-axis. And that's here. So looking at our values on the x-axis, we have 3, then we have 4, so therefore every little square here is going to be 2 grams, 0.2 grams. So this is 3.2 as our medium, 3.2 grams. We're now asked to find the upper quartile. The upper quartile is 75%. So using our ruler once again, we're going to plot where 75% of the students, and this is because our range is from 100. If our range was up to 90, then it would be 75% of 90. Okay, so let's not take 75 as gospel and use that value. It's just 75% here. It's going to be 75, the number of students 75, because we have 100 students. Okay, so 75% of 100 is 75. So if we had a range of 90 students or 80 students, then we would need to find 75% of that range, which would have been less than 75, okay? 75 students. So remember to calculate your 75% based on the amount of students you have, all right? Okay, back to our question. So our upper quartile, we're asked to find for our upper quartile, which is 75%. So And 75% of 100 is 75 students. So if this is 80 and this is 70, then 75 is going to be right in the middle here. So we're going up by 2 students. So 72, 74, 75 is going to be right here in the middle. So from this line, touching our curve and then onto our x-axis once again. So that's giving us a value here. And if we're to calculate that, remember every small cube is 2 grams. Sorry. Yes. So every small cube here is 2 grams, 0.2 grams, sorry. So we have 4.2, then this is going to be 4.3. Yeah, so 4.2, 4.4, 4.6, 4.8, 5 grams. So between 4.2 and 4.4 is going to be 4.3 grams. So our upper quartile is 4.3 grams. And that is the 75% of 100 students. Yeah. Semi-quartile range. So to find the semi-quartile range, it's going to be our upper quartile minus our lower quartile. So we need to find our lower quartile, and our lower quartile is going to be 25% of 100 students. Yeah, and if we to use our calculator, just so I make my point, 25% of 100 is going to give us 25%. But if our 25%, if our total amount of students were actually 80, then it would be 25% of 80, and that would be 20 instead of 25. Okay, so let's remember that. Anyways, back to our question. 25%, so we need to find 25 students, which is going to be 22, 24, so 25 is going to be smack in the middle here. So we plot our line across, touching our curve. Oops. Gives us here, and then we draw our line going down, which is here in the middle. So that's 2.2, 2.3 grams. So our lower quartile is 2.3 grams. LQ is equal to 2.3 grams. So we have our upper quartile at 4.3 grams minus our lower quartile as 2.3 grams. So subtracting this, we're going to have our answer as 2 grams. So our semi-interquartile, range is 2 grams. Yeah. And then moving on, it asks the number of students whose estimate is 2.8 grams or less. Yeah, 2.8 grams or less. Going back to our graph. So we need to find where 2.8 gram is. 2.8 gram is going to be here. So we need to now do the reverse of what we've been doing. So from our mass of seed, we need to find 2.8 gram, take it to our curve, draw a line to our curve, and then from the curve, we're going to draw a line connecting it to the number of students to find the number of students whose estimate is 2.8 grams or less. And that is here, which gives us 38 students. Remember, going up in 2, so 32, 34, 36, 38 students. And then finally, we're asked to use the cumulative frequency curve. Use the cumulative frequency curve on page 18 to complete the frequency table below. Okay, so we have 0 when our mass of seed is greater than 0, but it is less than or greater than 2. Looking at our curve, so it cannot be greater than 2. Therefore, that was 20, which is what they have there. So we need to look at our curve and write our values. So where our mass is greater than 2, so that's greater than 2 here, but it's less than or equal to 4, so that's our values from here, 20 to 4, so here. So 20 to 70, the difference. So that's here, our curve hits here for 4. So remember to take your values up. So 4, going straight up, it doesn't directly touch 70, it's around 69. So it's 69, take away 20, our curve is right on 20. So 69, take away 20 gives us 49. So that is our frequency. Remember to take away our values, okay? Let's not work in a hurry and write 69 as our value. So it's 69, take away 20 to get the difference of how many students are actually in this bracket here, okay? Now we're greater than 4, but less than or equal to 6, which gives us a range of value from 69. So let's write 69. 69. Range of values from 69 to here, which is 90, 92, 93. So it's going to be 93, take away 69, which would give us 24. Now let's add our values up to ensure that we have a total frequency of 100, because it's 100 students we're dealing with. So adding up our values, we can add 49 and 1, which gives us 50. 50 plus 20 is going to give us 70. 70 plus 20 is going to give us 90. Plus 4, 94 plus 6 gives us 100 students. So that is balanced. Our second part, it says a student is chosen at random. Find the probability that the student estimated the mass to be greater than 6 grams. So our mass, we need to find the probability that the student estimated our mass to be greater than 6. So that's from here going on. So the number of students, find the probability that the student estimated the mass to be greater than 6 grams. So the amount of students that are in that frequency is going to be 6 plus 1, which is 7. And the total amount of students to choose from is going to be 100. So it's going to be 7 divided by the total amount of students, which is 100 students. So 7 out of 100. Remember, it says to find the probability that a student estimated the mass to be greater than 6 grams. So these are the amount of students we can choose from below, because these are the amount of students that are in the frequency of greater than 6 grams. So that's 7 students over a total of 100 students, which gives us our probability of 0.07. Yeah. So that is our value, either 7 over 100 or 0.07. Question 6. The radius of each circle in the rectangle WXYZ shown below is 7 centimeters. The circles fit exactly into the rectangle. Okay. Show that the area of the rectangle is 2,352 centimeters square. So we need to show, excuse me, the area of this rectangle is 2,352 centimeters square. First things first, we know that the area of a rectangle is equal to length times breadth. Yeah? But we weren't given the length, we weren't given the breadth, we weren't given any dimensions other than the radius of the circle, which is 7 centimeters. Since it says the circle fits exactly into the rectangle, that means this is going to be 7, 7, 7, 7, 7, 7, 7, 7. And if we were to add all of these sevens up together, we're going to have our length. And as we know, the radius of a circle is constant throughout. So if this direction is 7, therefore this direction as well, so here, which is the same as here, is going to be 7 centimeters. So that's going to be 7 centimeters plus another 7 centimeter plus another 7 plus another 7. I think you get the drift of it by now. So that's 7 centimeters, 7, 7 centimeters, 7 centimeters, 7 centimeters. Yeah. So that's 1, 2, 3, 4, 5, 6 times 7 centimeters, which would give us our breadth or width as 42 centimeters, and then our length across, which would be the same 7 centimeters, so that's 7, 7, 7, 7, 7, 7, 7, 7, which gives us a total of 1, 2, 3, 4, 5, 6, 7, 8, 7. So that's 8 times 7, which would give us a total length of 56 centimeters. So all we're doing here is just adding up the amount of the total radiuses that we have here. So that's 7 plus 7 plus 7 plus 7. And we continue to get our length and add our sevens again here to get our width. Okay, so now that we know our width and our length, we can multiply. So our length is 56 centimeters multiplied by our breadth, which is 42 centimeters. And using our calculators, 56 multiplied by 42 will give us a value of 2,352, which is the same value as what we have here. Yeah, 2,352. I don't know why I keep saying 3,000. 2,352 centimeters square. Yeah, so that's how we prove our value. Moving on, it says to calculate the area of the shaded region. Okay. So the area of the shaded region is going to be here. Yeah. So in order to find the area of this shaded region, we'll need to subtract the area of all of these circles from the area of the rectangle. So the remainder of that area is going to be the leftovers in between, which is going to be the shaded area. So it's going to be area of shaded region is equal to the area of the rectangle minus the area of all the circles. Yeah. We know the area of the shaded region is going to equal to the area of the rectangle, which we calculated as 2,352 centimeters square minus the area of all the circles, and we're told to take pi to be 22/7. So area of the circle, as we know, is pi r squared. But we're not just multiplying one circle, we're multiplying all of the circles. So we need to know how many circles in total we have. So let's count. We have 1, 2, 3, 4, 8, 12. Yeah? 4, 8, 12 circles in total. So that's going to be pi r squared multiplied by 12 circles. Minus, so our pi r squared is going to be 22/7 multiplied by r, which is our radius, and that is 7 centimeters squared multiplied by 12. And using our calculators once again, 22/7 multiplied by 7 squared multiplied by 12 is gonna, multiplied by 12 is gonna equal to 1,848. 1,848. And area of our rectangle, which is 2,352, subtract that area, is going to give us a value of 504 centimeters square. 2,352 subtract 1,848 gives us 504 centimeters square. So that is how we find our answer for the shaded region. We subtract the area of our rectangle from the area of our circle. We subtract the area of the rectangle minus area of our circles. Yeah? Using that formula. So the area of the shaded region is equal to the area of the rectangle minus the area of the circles, all of the circles together. And that's what gives us our answer. Moving on. Yeah, so we're at B. And it says the diagram below, not drawn to scale, shows triangle M and P, in which angle M and P is equal to angle PMN. PMN is equal to 52 degrees and MN is equal to 12.5 centimeters. State the type of triangle shown below. So since our two angles are the same, this should automatically tell us that we have an isosceles triangle. Because once our angles here are the same, once we have two angles that are the same, opposite angles that are the same, our opposite lengths are going to be the same as well. So we know this is 12.5, therefore this is going to be 12.5 centimeters as well. So this is an isosceles triangle. And let's be careful of our spellings as well, okay? Moving on, determine the value of angle PNM. And this should be fairly straightforward. We know the total angle in a triangle is 180 degrees. We already know two angles, therefore to find the unknown angle, we'll have to subtract the total of these angles from 180 degrees. So angle PNM is equal to 180 degrees subtract 52 degrees plus 52 degrees, which would give us 180 degrees minus 52 plus 52 will give us 104 degrees, and subtracting that is going to give us our answer as 76 degrees. And part C, we're asked to calculate the area of triangle MNP. And looking at our triangle, we have two angles, we have two sides. So we can't use the half base times height triangle. What we do have is two sides and an angle. So we can use the half AB sine C formula, which would give us half AB sine C, and substituting our value, we know our AB, we know the two sides. Because of our isosceles triangle, we know these two sides are going to be the same. So it's going to be half 12.5 multiplied by 12.5 sine our angle here, which is 76 degree, side angle side, and putting that into our calculator, we're going to have half times 12.5 times 12.5 multiplied by sine 76 degrees, which would give us our answer as 75.8. Yeah, I'll leave it at 8. So 75.8 centimeters square. So that's the 1 decimal place accuracy. And that is how we find the area of our triangle that does not have a base, that only has two sides and an angle. We use our half AB sine C formula. Yeah. Question 7. A sequence of figures is made up of stars using dots and sticks of different lengths. The first three figures in the sequence are shown below. So we have figure 1, 2, and 3. Study the pattern of numbers in each row of the table below. Each row relates to a figure in the sequence of figures started above. Some rows have not been included in the tables. And we're asked to complete row 1, 2, and 3. Complete rows 1, 2, and 3. The first four rows have been completed for us. If we look and analyze our figures, we will see that we have 12 sticks as stated here in the first figure, and we have 13 dots. Questions like these, sequence questions, the first thing I like to do is identify a formula, so that when we get to questions like this where we need to fill in the table, we can just substitute our formula. Looking at our figure 1, we have 12 sticks, and then figure 2, 3, 4, it continues 12, 24, 36, 48. So from this, I can tell that the number of sticks S is equal to 12n, which is 12 times n. So substituting, we'll have 12 times 1, which is 12, 12 times 2, 24, and so on. And then for the number of dots, I can see we go 13, 25, 37, 39, which is just one more than the number of sticks. So that's just a +1. So I know D, which is the number of dots, is equal to 12n plus 1. So that's my two formulas that I'll use to find my answer. Completing 1 now, so we have the number of sticks when we have 5. When we're at figure number 5, it's going to be 12 times n, which is 5. 12n, 12 times 5 is going to give us 60. And then 60 plus 1 is going to give us 61. Same goes for here. So we know the number of sticks, 156. So 12n, 12 times the number is equal to 156. And that number n is going to be the figure. Since we know the number of sticks, we can find for n by dividing by 12. So 156 divided by 12 is going to give us 13. 156 divided by 12 is going to give us 13. Yeah? So our n is 13, and we know the dots is just our number of sticks plus 1, which gives us 157. And the last part of our question, n. So if we know n, if our figure is n, then the number of sticks is going to be 12n, which is exactly what we did here, 12n. And the number of dots is going to be 12n. I hope the shadow isn't too bad. So our number of dots is going to be 12n plus 1. And that is how we complete our table below. B. The sum of the number of dots in two consecutive figures are recorded. This information for the first three pairs of consecutive figures are shown in the table below. So we have figure 1 and 2 is equal to 13 plus 25. So that's for the dots. 13 plus 25. And then figure 2 and 3, we have 25 plus 37, figure 3 and 4, 37 plus 39, and so on. Determine the total number of dots in figure 7 and figure 8. So we need to find the number of dots in figure 7. So since we know our formulas for the number of dots is 12n plus 1, we can find for figure 7 the number of dots in figure 7. So that's going to be 12n plus 1. N represents the figure that we're speaking about, that number. So it's 12 times 7 plus 1. And substituting our value, we're going to have 12 times 7 gives us 84. Plus 1 gives us 85. And then we're going to have figure 8, which is 12n plus 1 again. So it's going to be 12 times 8 plus 1. And that's going to be 12 times 8 gives us 96 plus 1 equals to 97. So our total number of dots in figure 7 and 8 is going to be 85 plus 97, which gives us 182 dots. 85 plus 97, 182 dots. Now we're asked part 2, figure n and figure n plus 1. Okay, so for figure n, which is what we did here, figure n, to find the number of dots in figure n, it's 12n plus 1. So figure n is going to be it's figure n and our plus. Let's write our plus. So figure n plus figure n plus 1. Figure n, our formula was 12n plus 1 plus our formula for figure n plus 1 is going to be 12. And then our n value is now n plus 1. And then we finish our formula, which is plus 1, our formula for dots. Yeah? This is a bit tricky, so I hope everyone understands this. To find for figure n plus 1, this is our new n value. Yeah, n plus 1 is our new n value. It's our unknown. And then we continue our formula, which is plus 1. Multiplying across our 12, we're going to have 12n, which is 12 times n, and then we need to multiply 12 by 1. So it's going to be 12n plus 12 times 1, which is plus 12 plus 1. And this is going to equal to 12n plus 13. 12n plus 1, we write in 12n plus 1 again, and then adding all of this together. So we're going to have 12n plus 12n is going to give us 24n, and then 13 plus 1 is going to give us 14. So we're going to have 24n plus 14 dots. Oops, sorry. We're going to have 24n plus 14 dots as our answer.